Howdy! Welcome to Aspire Mountain Academy. I'm Professor Curtis, your instructor for this course in Introductory Statistics. In less than 10 minutes, this video provides practice using StatCrunch to conduct hypothesis testing and construct confidence interval estimates for two paired population mean values. Let's get started. So the example we're going to look at in this mini lecture involves body temperature. So there are 4 subjects that were selected, and the temperature in degrees Fahrenheit was measured for each of these subjects at 8 a.m. and at noon. So here we have an example of paired data, because for each data point in the one group, there's a unique data point in the other group, and those groupings that the pairs off all have the same relationship. So these 2 data points have the same relationship of being from the same subject. These 2 data points have the same relationship of being from the same subject. And so what we have here is an example of paired data. Notice we're asked our typical standard questions about the hypothesis testing and the confidence interval. The claim that we're asked to evaluate is that the body temperature at noon is on average higher than the body temperature in the morning. And so we're going to be looking at these questions with respect to this claim. First question we're asked is about our hypotheses, and of course, to test the hypotheses, we're going to be looking at, the first thing is to look at the claim. So what is the claim that's being made here? Well, it says the body temperature is higher at noon than at 8 a.m. So that means we're actually going to use the 8 a.m. first as our subscript 1, because here in the problem statement, the 8 a.m. sample is actually mentioned first, and then the noon one is mentioned second. So we're going to set it up this way. And that means that 1 minus 2 is going to be less than 0. If the second temperature is going to be higher than the first, then the first minus the second will give us a negative number, so it's going to be less than 0. Of course, we're dealing with matched pairs here, so mu sub d is going to be the notation of choice here. So mu sub d is going to be less than 0. As always, null hypothesis is by definition a statement of equality. So we can write that out simply as mu sub d equals 0. And then the alternative hypothesis, that generally we take that from the claim. There's no semblance of equality here with the claim, and so therefore we're just going to adopt that claim as our alternative hypothesis. Notice here that we've got that inequality sign. It's like an arrow pointing to the left. So we've got a one-tailed test on the left side of our distribution. Next, we're asked about our test statistic. It's way easy to get this if you're using StatCrunch. So we've got data. Let's just dump it into StatCrunch and then go to Stat, T-Stats paired. And then in the options window, notice up atop, we're putting in the columns where our sample data is located. So 8 a.m. mentioned first, so it goes into sample 1. And then noon is mentioned second, it goes into sample 2. Generally, we're going to leave that value in the claimed value area for the hypothesis test alone. All we're going to need to do is make sure we match that alternative hypothesis and equality sign, make sure that matches, and then away we go to get our results table. And as always, the test statistic is that second to last value there in the results window. P-value is always the last value listed there, so it's right next door to the test statistic, as we've seen previously. Are we going to reject or fail to reject the null hypothesis? Well, are we inside or outside that critical region, that region of rejection? If we're outside, we fail to reject. If we're inside, we reject. So here we've got our distribution, student t distribution. 4 degrees of freedom because we've got a sample size of 5. And if we put in our alpha here, 5%, this gives us our critical region in the left tail of our distribution, because we have a left-tailed test, a one-tailed test on the left. And the boundary for that tail region is going to be our critical value, so negative 2.13. If we go back to our results table, look at that p-value, we can compare it with our alpha of 5%, and we see that we're just barely outside. And it doesn't matter whether you're outside by a lot or a little, Outside is outside. So because we're outside the region of rejection, we fail to reject the null hypothesis. Next, we turn our results into an actual conclusion that we can word so other people can understand it. It's the same pattern that we've seen here before. So for this hypothesis test, we fail to reject the null hypothesis. Therefore, there is not sufficient evidence, and we have a one-tail test. Therefore, we want to support the claim, and that means we're going to select answer option B. Note here where each part of this actually comes from. Okay, we failed to reject the null hypothesis, so there is not sufficient evidence. We have a one-tailed test, so that leads us to support the claim, and then the rest of the statement is just a rehash of the claim itself. What is the appropriate confidence interval? No, it says appropriate. It doesn't give you what the actual confidence level should be. So we have to determine that, and that's pretty easily done. We had a match between our alternative hypothesis and our claim, and so therefore we're going to use 1 minus 2 alpha to calculate our confidence level. So going back down to our options window, click on that radio button for confidence interval, and we're going to put 90% in for our confidence level, because alpha is 5%, 1 minus 2 alpha will then be 90%. Then we press compute and get our results window. The upper and lower limits are there on the end of the table. You can read that, round that off to as many decimal places as we need to get our confidence level. What do we conclude from these results? Well, is 0 inside or outside the confidence level limit? So inside the confidence interval, we find that 0 is just barely inside. And so inside is inside, so therefore it could be the answer, and therefore there's no significant difference on average in body temperatures between 8 a.m. and noon. So in other words, body temperature seems to stay fairly constant in the morning. Okay, again, there's insufficient evidence to support the claim that there's a difference. And that brings us to the end of this mini lecture. I hope you found it helpful. You can find more mini lectures for this and other courses at AspireMountainAcademy.com. Thanks for watching. I'll see you in the next video.